Today we are going to do the third part of our video tutorial series on trig integrals. And as I mentioned in the first part, trig integrals are integrals which have trigonometric functions in them. And so far we considered two types. We learned how to attack two types. Now one type was when we have a sine and a cosine integral, but either the sine or the cosine having an odd power. And then we learn the way to attack that would be to remove one of the odd powers and reserve it at the end and convert the remaining even power by Pythagorean into the opposite and then use u equals opposite. Now the other type that we did was when we have a secant tangent integral with the secant having an even power. The attack was to remove one secant squared from that even power and reserve it at the end with the dx and then convert the remaining secant even power into tangent by using the Pythagorean and then put u equals tangent x. That was the second type, and now we are going to study the third type of integral. This is a kind of a painful technique in the sense that it is maybe not as elegant as the techniques that we used in the previous two cases. Now we are specifically going to deal with integrals which have sine and cosine, but both powers being even. For example, if you look at an integral like cosine squared x, now we have just the cosine and the power is even. Okay, and for another example, if we have the integral of sine squared and cosine squared dx, once again we have only sine and cosine and the powers are both even, not a single one of them is odd. Now before we learn how to attack this type of integral, we must review some topics from trig. Now you may remember that in trig we had a double angle formula. The double angle formula for cosine was cosine 2x was equal to 2 cosine squared x minus 1. Well, there were actually three of them, but one of the double angle formulas was cosine 2x is equal to 2 cosine x minus 1. Now if you solve this for x, or cosine x rather, what happens is you can take the 1 over to this side and then you get 2 cosine squared x is equal to cosine 2x plus 1. So if you want to now solve for cosine squared x, we will get cosine squared x is equal to 1 plus cosine 2x over 2. So notice that we were able to write cosine squared using the double angle cosine 2x as cosine squared x is equal to 1 plus cosine 2x over 2. Now if you can recall, there was another double angle formula for cosine 2x, and that was cosine 2x is equal to 1 minus 2 sine squared x. Now using that, now previously we solved for cosine squared. Now using the similar argument, we can now solve for sine squared x, and then we will get sine squared x is equal to 1 minus cosine 2x over 2. So remember, cosine squared x is equal to 1 plus cosine 2x over 2, and sine squared is equal to 1 minus cosine 2x over 2. Now we will need these two formulas when we attack in the case of even powers for sine and cosine. Now let's take this integral. Now we have cosine squared x, notice even power, so we cannot use any of the previous techniques, right? We have to try a new technique, and the new technique is very easy to state. Okay, and that is, what we do is we take the cosine squared x and replace wherever we get the cosine even power or cosine squared x, we replace it by the corresponding double angle formula. So cosine squared x is equal to 1 plus 2x over 2 from formula 1. What we do is we take that and replace this by that. So you notice that in the next step I have replaced cosine squared x by 1 plus 2x over 2. Now actually we are ready to integrate this, and so now how do we integrate this? First of all, you have 1/2 right? Okay, and if you integrate 1/2, you will get 1/2 times x. And then you have cosine 2x over 2, you need to integrate that. So you have, and then if you take the 2 outside, you will get 1/2 integral cosine 2x. Basically what I'm trying to say is that take this part away, you get 1/2 x, and if you just concentrate on this part, you will get 1/2 integral of cosine 2x. It is pretty easy because the integral of cosine 2x is equal to sine 2x over 2. So the answer would be 1/2 x plus 1/2 sine 2x over 2 plus c. And that's the answer. Now let's look at kind of a more cumbersome question. Suppose we need to evaluate integral of sine squared x cosine squared x. Once again, there is no other way out rather than replace the sine squared x and the cosine squared, let's write x here, by the corresponding double angle formula. So we go up there, and then we notice the sine squared x is 1 minus cosine 2x over 2, and then we go up here, we get cosine squared x is 1 plus 2x over 2. We plug in those values here. So sine squared x becomes 1 minus cosine 2x over 2. Cosine squared x is 1 plus cosine 2x over 2. Now, if you look at this is like a difference of two squares, like a minus b, a plus b. So if you distribute it out, you will get the square of 1, which is 1 minus the square of this, which is cosine squared 2x, and below you get 1/4. Now once again, you can separate the 1/4 and integrate that one, and then you get 1/4 x. And then you're left with minus 1/4 integral cosine squared. So this part will become integral of cosine squared 2x, and the 1/4 goes outside. So now, what do we do here? Now again, if you look at this integral, we're kind of stuck because again we have a cosine even power. So what we do is, for this cosine, now remember, when you had cosine squared x, go up here, cosine squared x was 1 plus cosine 2x over 2. So if you have x here, we have 2x here. Which means if you have 2x here, then we will have 4x here. Which means that cosine squared 2x is equal to 1 plus cosine 4x over 2. So we have 1 plus, what we do is, we take cosine squared 2x is 1 plus 4x over 2, and we put that here. Once again, do note that to get rid of the cosine squared, we used a double angle formula, but this time for 2x, so which means you get 4x. So put that here, you get 1/4 x minus 1/4 1 plus cosine 4x over 2, and then you get 1/4 x minus, and then you get 1/2 from here, you get 1/8 x. So if you take this part, you get 1/8 times the integral of 1 would be x, and then finally you get 1/4 times 1/2 is 1/4 cosine 4x. Okay, this is kind of wrong. I think what you should do, come here, cosine, so cosine 4x should be inside this, right? Okay, and now we can integrate, and then you get 1/4 x minus 1/4 x plus 1/8, and the integral of cosine 4x is sine 4x over 4, and that is your answer. So, that's it for this class. And then, okay, so then we have the answer as I is equal to 1/8x plus 132 sine 4x plus c. And then I will leave you with a video exercise, which is to evaluate sine squared x, just to integrate sine squared x. Now once again, our technique, to summarize, whenever we have an even power, we replace that with the double angle formula. So cosine squared x became 1 plus cosine 2x over 2, and here sine squared x became 1 minus 2x over 2, and cosine squared x became 1 plus 2x over 2. And even here, when we wanted to do cosine squared 2x, we put what? 1 plus cosine 4x over 2. So the moral of the story is that whenever you have a sine squared or a cosine squared x or a cosine squared 2x or a cosine squared 5x or whatever, or sine squared 5, you have to replace by the corresponding double angle formula. Either if it is a cosine squared, then 1 plus cosine double angle. If it's a sine squared, then 1 minus cosine double angle, and then integrate. Okay, that's it for today. I'm going to leave you with a video exercise once again.